The site chosen by my study group was 116 Bathurst Street, Sydney, also known as Castle Residence. Castle is a 37-floor mixed-use residential and commercial project being built by Hutchinson Builders. Over a period of visits to the site, the team was tasked with observing the process and productivity of steel reinforcement placement. The team engaged with subcontractors, site managers and engineers to encompass the full scope of the trade.
During our visit, the site was in heavy production with a variety of work processes occurring at similar intervals around the site, which was a good sign of productivity and efficiency through the well thought out and planned use of spaces, which through the images of the site is clear that there wasn't much of in the first place, which is expected in a project such as this. And as everything's under tight limitation, many materials were required to be held and interacted with on site, in the middle of the floor spaces or immediately next to where the materials were required. And this allowed for the on-site productivity to carry well throughout the project's life cycle. The workers seemed to be well acquainted with their workspaces, as many tools and necessary equipment were located as close to where they were needed as possible, as close as the given space allowed them to be, as seen in these photos. However, regardless of these material holding locations, most of the material posed a hazard if carried by a single individual due to their large and varying weights as well as its longer shapes. This meant that 2 people, at the minimum, would be required to carry these materials around the tight corners, and sometimes requiring more in order to effectively transfer materials to where they were needed. And during our visit, we were able to witness this and how inefficient these methods were, as when the builders would stop their work in order to help, they would often stand idle for a period of time and take a considerable amount of time in order to be able to pick up where they left off before leaving their work. In another area of the site, during the concrete pouring stages, there were many idle builders that seemed to be assigned to the pump process or there for other reasons. However, as seen in the video, multiple workers remained idle and unproductive, which could have significantly impacted the planned and actual delivery times of the concreting process. However, after speaking to the project manager after this pour, there were no delays and noticeable impacts of unproductivity during this time. However, during the pour, we were able to speak to some of these workers that were participating in the pour process, and we were able to hear their suggestions on improving the action of pouring the concrete. That in turn would improve productivity. This ranged from clearing the area from most debris that would make traversal through or around the workplace more simple and thoughtless, as well as removing any other working individuals that were unrelated to the pour, as they were able to interfere or slow down the process, as well as organizing a better schedule for a better utilization of space during the pour. All of the suggestions from the workers come from first-hand experience and would indefinitely improve the productivity of all aspects of the site regardless of what process is being undertaken. Regardless of the site's minute issues and occasional idle workers, the workflow on the site during our visits seemed to be quite continuous and expansive, as a variety of workers in different trade professions were on site focusing on different sections of the project, and were effectively scheduled and planned to, for the most part, stay out of each other's ways. And in most occasions, most of the trades didn't have any excess workers that were there without purpose or work, and all the individuals on site had a reason to be there at those certain times, aiding other workers to complete their work, or simply working on a section of the project on their own. However, all in all, the project workflow was stable and productive throughout all parts of the site that we had access to.
The site at 110 to 118 Bathurst Street, Sydney, utilises a boom pump to carry out the concrete pour. Boom pumps are concrete pumps that uses a remote-controlled articulating robotic arm, otherwise known as a boom, to place concrete accurately. Boom pumps are often used on most of the large-scale construction projects, as they are capable of pumping high volumes of concrete, as seen in these images. The boom pump that we witnessed on site was guided by 2 site members, as well as having 2 other site members to supervise the pour. The reasoning behind the utilisation of the boom pump for the site is mainly due to the fact of the large amounts of concrete that need to be poured, as well as the boom pump being ideal for being able to get concrete poured into spaces that are obstructed, as the boom pump can navigate over and potentially around these obstructions, thus emphasising its flexibility. In addition to this, a major piece of equipment used on the site was the jump form, which is a system comprised of formwork and working platforms for cleaning and fixing of formwork, steel fixing, and concreting. In relation to this, the formwork supports itself on the concrete cast so it doesn't rely on support or access from other parts of the building or even permanent works. As stated by the project manager, jump forms are essential for a site of this scale as they provide the benefits of reducing construction time, enabling higher quality surface finishes to be achieved, contributing to an ease of planning construction activities due to the repetitive nature of work, as well as reinforcing safety measures through incorporating working platforms, guardrails, and ladders into formwork systems. Furthermore, when we asked the project manager of the Bathurst Street site about the uses of pre-cut or prefabricated assemblies used on site, he stated that nothing as of yet was prefabricated in nature. However, in future stages of the project, they had plans to implement precast walls into the structures. Precast walls are walls that are usually assembled off-site and transported to sites to be installed. Aside from the main benefit of reduced assembly time, the project manager stated that the decision behind the choice of precast walls was driven by reduced costs in the form of project schedules being compressed, reducing site disruption and reducing overall project costs as fewer trades were required for construction of the walls, as well as precast walls being perfect for absorbing sound, thus enabling it to meet sound resistant requirements for multi-residential buildings.